Hello guys. Today I'd like to record the online session of today to help you to study well for the third quarter exam and for the quiz that will be on the next Thursday. Okay, now let's remind you by this lesson in worksheet 6, which is the extrema of a function. And I already mentioned this lesson or the concepts of this lessons in the revision sheet. We solved examples included this concepts. At the beginning, I'd like to define the extrema. What is the meaning of extrema? We mean the minimum value of the function or the maximum value of the function. Let's define what is the meaning of absolute minimum and absolute maximum. Look here. Let f be a function. Okay, defined on a closed interval containing point C on an x. We say f at x equals c, minimum value of the function if it is fc less than or equal fx for all x in I. What is the meaning of this one? Smallest value. Smallest what? Value of fx in this interval. This is closed interval. Okay, and we can say fc is the maximum value of f on the closed interval I if the value of f at x equals c greater than or equal all of the value of fx for all x in the interval I. By another way, it means the greatest value of fx on this interval. Okay, we know the extrema is a plural of extremum. Friend asked me question, Miss, what is the meaning of absolute? Why we say absolute? We mean absolute, it means absolute minimum. This means the function has no value less than the minimum value of this minimum value of this what? Minimum value. That is why we name it absolute. There is no value of fx less than the absolute minimum value. Absolute maximum, it means the function has no value greater than the absolute maximum value. Okay. Here, I'll show you something very, very important. Please focus with me. Here, as you see from the graph, the least value of the function at 0 and 1, at the ordered pair 0 and 1, and the function has maximum value at the ordered pair 0 and 2. Here we discuss the extrema on a closed interval, what? -1 and 2. Since we discussed the extrema on a closed interval, we name it absolute maximum and absolute minimum. Okay? As you see here, the function is defined at the minimum value and defined at the maximum value. But if we draw a function like this one, we can't name fc, which is undefined already, is the minimum value. Why? Because the function here is not continuous, or by another way, undefined. So, in this case, this function has no minimum value because the function undefined at this value. Okay? Now, here we have a theorem, extrema value theorem, or extreme value theorem. If a function is continuous, it is very important to know the function must be continuous, okay, or defined on a closed interval AB. Closed interval, that is the left end, that is the right end of the interval. Then f has both minimum value and maximum value on the interval. Okay? If we discuss the extrema of the function on a closed interval, so the function will have what? Minimum value and maximum value. Okay? Here, when we talk about the extrema, the maximum value or minimum value in a closed interval, we name it absolute maximum or absolute minimum. Okay, but here we will define a new concept, okay, which is relative, relative extrema. When we discuss the greatest value and the smallest value in the function on an open interval, so we name it relative maximum or relative minimum. Not, but when we talk about absolute maximum, we can say absolute maximum and relative. Means I don't understand what is the meaning of relative. We mean by the relative, it means, look here, I'll show you. Look, for example, like this function. Okay, this value, minimum value, can we say this value at, this is on an open interval, this function fx, okay? Look here. At the point A, the function has a minimum value, yes, but we name it relative because we talk about the function on an open interval. Okay, how? Relative, it means if we compare the value of the function fa with its neighbor, the value of the function in its neighbor before it and after it, okay? In this case, for all of the values of x greater than a, the value of the function increase, as you see, okay? And for all of the values of x less than a, the function is what? Increase. Since the function here, sorry, here not increase, I'm sorry, decrease. Because as x increase, the function decrease. Here's the function increase. The behavior of the function is changed from decrease to increase, so this one is called minimum. Or by another way, I compare the value of the function with respect to the value of x in its neighbor. It is the smallest value, okay? And by another way, I can say this point is what? This point as the absolute minimum because this function goes to negative infinity. The function has value less than fa. Less than fa. So I can't say absolute because absolute minimum, it means that is the least value of the function. The least value of the function. But fa here, it is not the least value of the function. The function has many values less than fa, but it has many values. So I can say it is what? Absolute minimum. This one also, we name it relative maximum because it is greater than the values of the function in its neighbor. In its what? Neighbor. Its neighbor, in this case, we say relative, but I can say absolute by another way. When we talk about the extrema on an open interval, we say relative maximum or relative minimum. Okay, but when we talk about the extrema on a closed interval, we say absolute maximum and the absolute minimum. But sometimes, if we talk about the function like quadratic function, which up into down like this one, it has maximum what? Value. We can name it absolute because it is the greatest value of the function, no function greater than it, and we can name it relative. Any absolute can be relative, but not every relative as absolute maximum. As you see here, this one relative maximum, and in the same time it is what? Absolute maximum because it is the greatest value of the function. Okay? Now, I mentioned for this definition in the revision sheet, what is the meaning of critical number? The critical number are the values of x at which the derivative of the function does not exist or equal 0. The derivative equals 0 or not differentiable, or by another way does not exist. Okay? In this case, I'd like, from the graph we can identify the critical number. The critical number, the values of x from the graph, not analytically. From the graph, as you see, if the function has corner, if the function has what? Corner, as you see. So at the corner we have a critical number, or at sharp point. At a sharp point, it is what? Critical number. Or at cusp, we have what? Critical number. All the critical number are the values of x. Here, all of these, okay, values of function, the derivative, equal what? Does not exist. Does not exist. From the graph also, the values of x at which the graph has a horizontal tangent, it is called critical number. يبقى critical number, the values of x at which the graph has a corner, cusp, sharp point, or it has a horizontal tangent. This is from the graph, okay? Now, I'll show you these steps, how to find the extrema in a closed interval. You have to follow the steps or follow the instruction of this one. Here, before I'll show you later this one, it's so easy as I showed you already in the revision sheet when we solved. Okay, now, here, I'll ask you a question here. Find the value of the derivative if it exists at each given extremum. As you see in question 1, where the given point here, 0 and 0, which is the extrema. Here it is what? Absolute minimum, and in the same time, relative minimum, because any absolute can be relative. Okay, what is the derivative of, what is the value of the derivative? As you see here, the derivative at the extrema, 0 or does not exist. If it has a horizontal tangent, as you see, so the derivative here of the function at 0, it will be what? 0, because it has a horizontal what? Tangent. Here, as you see also, this extrema and this extrema, absolute minimum, sorry, not absolute minimum, relative minimum, because maybe I have less than it. As you see, this function goes to negative infinity. Relative, this extrema and this one, extrema, which is what? Absolute, sorry, relative maximum. And this one, relative minimum. Here, as you see, it has a horizontal tangent, I will write f prime 0, it will be 0. F prime, the derivative at the extrema, at the point at x equal to, it will be what? 0. Okay, the derivative. I hope you understand. Now, for the next question, here, as you see, the derivative here also, it's so easy, miss, because it has a horizontal tangent. The derivative at the critical number, which is what here? 2, or at the extrema at the point 2 and 3, it will be 0. Here, what is the derivative here? Derivative is what? Horizontal tangent. So, it will be f prime at negative 2 over 3, it will be what? 0. Clear or not clear? So the derivative equal 0 at this one, which has a horizontal tangent. Here, for this one, I think it's so trivial for you to know. It has a corner at this critical number, because at the extrema we have a corner, sharp point, we have cusp, we have a horizontal tangent. At this critical number, negative 2, which we have a relative minimum value, the derivative equal what? Does not exist, because it has a corner. Also, at the extrema here, at which point 0 and 4, the derivative at this x, it will be what? Does not exist, because the function not differentiable, or it has what? Sharp point. Sharp what? Point. I hope you understand. Okay? Here, please focus with me. I have to identify how many requests in the question. The first one, approximate the critical numbers. What are the critical numbers? The values of x at which the graph, since I'm talking about the graph, I have to know critical number occur at corner, sharp point, cusp, or at horizontal tangent to the graph. Okay? So that is the first request, find the critical number. The second request, he asks you to what? Determine whether the function has a relative maximum, a relative minimum, an absolute maximum, an absolute minimum, or none of these at each critical number on the interval shown. Look here. It's so clear. At 2, we have what? Relative maximum. And it is the greatest value, so it is what? Absolute maximum. Critical number, any extrema occur at critical number. But not at each critical number, we have an extrema. Okay? Here, we have a critical number at what? This extrema. So, what is the critical number in this case? Is what? X equal 2. That is the critical number. A critical number at the extrema, at corner, at horizontal tangent, at sharp point. That is the critical number. Okay? But not at each critical number we have extrema. Okay? Now, here in this case, we will name what? We have absolute. Why? Because it is the greatest value of the function. There is no greater than it. Absolute what? Maximum. Means, but here we talk about open interval. I know we talk about open interval, but it is the greatest value of the function, so we can say absolute. And in the same time, we name it relative maximum. Okay? Clear or not clear? At what? At 2 and 4. Okay? Clear or not clear? Here, approximate the critical number. I'm searching for the values of x at which the graph has a horizontal tangent, cusp, a corner, sharp point. Then identify it is absolute maximum or relative or what else. But I'd like to tell you something very, very important. The extrema occur at the critical number if the behavior of function is changed from increase to decrease or from decrease to increase. Let me see you this one. In this case, at this critical number 2, the function change the behavior from increase as x increase, it is a function increase, to what? Decrease. Since the behavior of the function change from increase to decrease, we have absolute maximum or relative maximum. Okay? Clear or not clear? So, at any critical number, we have extrema if the behavior of function change. If the behavior of the function does not change, I don't have extrema. It is very, very important. Let's see number 8. At point 0, we have horizontal tangent. So, where is the critical number here? X equal what? X equal 0. Critical number at x equals 0. Means here, I told you, if the behavior of the function doesn't change from increase to decrease or decrease to increase, so I don't have. In this case, what is the behavior of the function? Increase. As x increase, the function increase. And here, in this case, increase. Since the behavior of the function here doesn't change from increase to decrease, still increase. So I don't have. In this case, function fx has no extrema. Clear? Or has no none of these. None of these, okay? It's clear or not clear? Extrema occur at critical number if the behavior change from case to another case. Okay? Now, in this case, in question number 9, okay, in question number 9, how many critical number? What are the critical number? Try to pause the video and answer, then check your answer. Here, as you see, at x equal here, here, and at here. Here we have absolute maximum, absolute maximum, absolute minimum, or we can say relative. Okay? In this case, we say at x equal 1, 2, 3. Okay? 1, 2, 3. Okay? Here at 1, the behavior of the function changed from increase to what? Decrease. So, the function, absolute maximum, and we can say what? Relative. Maximum, okay? At what? 1, 3, and 3, 3. I have maximum at this ordered pair. But at 2, absolute minimum or relative minimum. Why we say absolute? Because it's the smallest value of the function. I don't have less than it. Okay. Or relative, because if we compare it with its neighbor, the value of fx in its neighbor, it will be the smallest value. At what? 2 and 0. Okay, I think it's so trivial. It's so easy. Okay? Now, in this case, it's so trivial also. I have here critical number at 2, critical number at 5, critical number at 2, x equal 2, and equal what? 5. At 2, the behavior of the function, you have to ask yourself, increase, and here what? Increase, as I solved in number 8. Since the behavior of the function does not change from increase to decrease or decrease to increase, so it is what? No, none of these. At 2, 2, none of these, or has no extrema. No extrema at what? 2 and 2, at this critical number. Okay? At critical number 2, we don't have extrema. Okay? Or at x equal 2, by any way. Here it's so clear. At x equal 5, we have what? We can write this one, we have maximum value, or can we write maximum, absolute maximum, or relative maximum? Okay, at x equal what? 5. You can write this. Clear or not clear? Okay? At any critical number, we have extrema if the behavior of the function change from increase to decrease. Okay? Or decrease to increase. Otherwise, we don't have extrema. That it's a condition. Okay? I mentioned for this question in the revision sheet how to find the critical number. I find the derivative, the first step in all, find the derivative, then find the zeros of the derivative, or when the derivative does not exist. Since we have a polynomial function, only 2 steps. Only 2 steps. If we have a polynomial function, find the derivative. I'll solve only the first one, and you will solve the others one. Then check the answer from the model answer, which I posted already on LMS. I'll I posted already the videos of the revision sheet, the model answer of the revision sheet. I posted already on LMS. We have a quiz on the next Thursday. Okay? It will be 3x squared minus 6x. That is the first step. Find the derivative using the basic rule of differentiation. Then put the value of the derivative, 3x squared minus 6x equals 0. When I wrote the model answer of worksheet 6, I wrote all of my explanation, okay? Implies 2. Take 3x as a common factor, it will be x minus 2, it will be 0. So critical number from here, x equal what? 0 and 2. The zeros of the first factor and the zeros of the second factor. That is these are the critical number. By the same way, you can solve the rest. Okay? Here, I solve on the first example and the others question as a homework. Then check the result or your answer from the model answer which I post on LMS. Now here, so trivial. As I told you in the theorem, when discuss the extrema on a closed interval, so I have absolute minimum and the absolute maximum. Okay, we have both minimum and max. Here I solve it in 4 steps. Step 1, step 2, 3, 4. Okay? I'll help you to solve the first one, then the others one it will be at the homework, and check your answer from the model answer of the worksheet. Here, find the first step, find the derivative. Find what? The derivative, which is what it will be 12x to power 3 minus 12x squared. Clear? Second step, find the zeros or the value of x at which the derivative does not exist. But since we have a polynomial function, as you see, okay, I'll find the zeros of the derivative. 12x to power 3 minus 12x squared equal what? 0. Implies, take 12x squared as a common factor. It will be x minus 1 equal what? 0. Okay, then from the first factor x equal what? 0, or from the second factor x equal what? 1. X equals 0 or 1 are the critical number. The first step derivative, second step critical number. Third step, make a table. Make what? Table. Table, sorry. Here, critical number. Here, derivative. Okay? Now, make a table here. Focus. What I write in the table, the first row, I write the values of x. Second row, I write the values of y. What we write the value in values of x here? Look here. Please focus. The first value will be the left end, -1. And here, the right end of the interval. The left end of the interval, right end of the interval. Clear? Between them, I will write the critical what? Number, which are 0 and 1. Sometimes I have one critical number, no critical number, or 2, 3, any number of critical. Maybe I don't have critical number. In this case, I will write what? The left end and the right end of the interval only. Okay? Then, substitute in the original function. Substitute in the original function. Okay? -1 in this, so the first one, it will be 3 minus plus, it will be 7. That's right. -1, it will be 1, or 3, 7. And 0, it will be 0. At 1, it will be -1. At 2, it will be 16. So, the first step, I find the greatest value here, it will be maximum value. It will be what? Maximum value. Okay? The least value, it will be what? Minimum value. The first step, derivative. Second step, critical number. Third step, make table, substitute in the original function. The greatest value, it will be absolute maximum. The smallest value, it will be what? The smallest value, it will be absolute minimum. In this case, we will say absolute maximum at which ordered pair x and y, 2 and 16. Absolute minimum at which ordered pair x, 1 and negative 1. I think it's so easy and trivial. I have to follow the same 4 steps. When you do the quiz or the quarter exam, you have to prepare blank paper, pencil or pen, whatever, calculator to solve, then choose your answer. Choose the answer or choose the correct answer according to your solution. Clear or not clear? In this case, I leave you to solve the rest of the question as a homework. It's so easy, by the same way. And the model answer, most of the model answer in what? The revision sheet. Follow the same steps. But if you have the derivative is a rational number, function, I have to find the zeros of numerator, zeros of denominator to find the critical number. Okay? Here you can solve the rest. It's so easy. Okay, this one. But here, if I say locate, someone ask me, Miss, what is the meaning of locate? Locate here, it means the ordered pair x and y at which the function has absolute maximum or absolute minimum. Grade 12, please revise all of the given revision sheet. Study the basic rule of differentiation, the revision sheet, all of the model answer already posted on the LMS. See the videos if you don't understand anything in the revision sheet. Any missing question you have to solve and check your answer from the model answers of the worksheet 6 and the revision sheet. Have a good luck, inshallah, and prepare yourself well, study well for the quiz that will be on the next Thursday. Thank you. Bye-bye.